Hello everyone, thank you for another special time together. Today we are going to look at the calculation that we have on the board that has to do with calculating the resulting gases in a chemical reaction. In this one, the question says 40 cl³ of carbon 2 oxide is mixed and sparked with 200 cl³ of air containing 21% of oxygen. If all the volumes are measured at s.t.p, calculate the volume of the resulting gases. So here we have the chemical equation for us. It's already given to us and we are to calculate. The question says we should calculate the resulting gases, that is the gases the gases that remain after the chemical reaction. So here now, what we are going to do here is to consider their relationship from the chemical equation that we have here. We can see that we have a ratio of combination, just like what Gay-Lussac said. They combined in a ratio of 1:2:1:2, and in this ratio is what determines the volume of their reaction, the volume that can react with each other to give us the product. So here we are given 200 cl³ of air containing 21% oxygen. So the first thing we are going to do is to get the volume of oxygen that is contained in 200 cl³. So what we're going to do now, we first get the volume of the oxygen. Volume of oxygen in 200 cl³ of air. So that means say 21%, that means 21/100 times 200/1. That will give us, this can cancel out, we have is equal to 42 cl³. So in this 200 cl³ of air, what we have there is 42 cl³ of oxygen. 42 cl³ of what? Oxygen. So and the rest of the gases there, there are other gases there which might not, the other gases are not part of, they are not going to take part in the chemical reaction because they don't support combustion. So in that case, we can also get the volume of the remaining gases, other gases in 200 cl³ of air. The other gases include nitrogen and noble gases. So that means we have 200 minus 42. What we have here should be 851 cl³. 851 158 cl³ of the gas. Now, since we have the volume of oxygen present in the 200 cl³ of the air, we can now go ahead to find out what happened between this oxygen and carbon 2 oxide. Between the carbon 2 oxide, so let's see what happens between them. Now, between the carbon 2 oxide and oxygen, we notice from our chemical equation, this chemical equation is showing us that 2:1. That means 2 cl³ of what? Carbon 2 oxide will react with 1 cl³ of what? Oxygen. 1 cl³ of oxygen. So that means since we have 40 cl³ of carbon 2 oxide, that means we're going to find out what's going to, that means 40 cm cube, we're going to find out what will happen here, because 40 cm cube is going to react completely. We expect it to combine completely with what, with the oxygen, in order to give us what we are looking for. So what we have here, that means 40 cm cube will react with 1/2 times 40 over 1. This will cancel out. We have 20 cm cube. 20 cm cube. Now, according to Gay-Lussac's law, say that the combination is based on their what, simple ratio with one another. In the ratio of the combination, we're able to find out that since this one is 2, that means this one. Since this one is 2, this one is 1. That means we're likely to get something like this to combine. That is half of the 40 is what is going to combine with 40 cm cube of carbon 2, according to the Gay-Lussac's law that states that they combine in a ratio. That's a simple ratio. This is the simple ratio of their combination. That means as we are going up, we will still maintain this ratio as time goes on. All right, as the reaction continues. So what we have here is 20 cm cube. 20 cm cube of oxygen. Having done that, it means that in our 42 cm cube of oxygen, the only thing that reacted is 20. In other words, we still have an extra gas that will remain, oxygen that will remain there. That means 42 minus 20 will give us 22 cm cube. This is gas that did not react, oxygen that did not react. Volume of cm cube of oxygen which did not react with carbon 2. So this is the volume that did not react with carbon 2. So this is going to play a very important role. We can keep it somewhere here. And then the other one, our other gases, will have 158 cm cube. So at the end of this reaction, we notice that 20 cm cube will disappear with 40 cm cube of this to give us carbon 4 oxide. So we'll look at this. Since we are looking for what, resulting gases. Resulting gases are the gases that will remain after the chemical reaction. So at the end of this, when these two 40 cm cube combines with 20 cm cube of oxygen, it will give us carbon 4 oxide. Now the volume of carbon 4 oxide that reacted, that is produced, we can also get it by looking at the ratio of their reaction according to Gay-Lussac's law. So in this simple ratio, we will be able to find out what happens here. It means that 2 cm cube of this will give us 2 cm cube of carbon 4 oxide. That means since we have 40 cm cube, 40 cm cube of this will then give us 2/2 times 40 over 1. That will cancel out. We have 1 and then the end of this game here we have the product we have here is going to be don't mind me please, it's going to be 40 cm cube. The carbon 4 oxide that will be produced will be 40 cm cube. This plays a very important role. That's a part of our what, resulting gases. At the end of this reaction, what will remain here is going to be what the remaining gases or resulting gases that we have at the end of this reaction is, we have the volume of oxygen which did not react is what, and we say it's 22 cm cube, and the volume of carbon 4 produced is 40 cm cube. Then the next one we have here is the volume of other gases. Gases like noble gas and nitrogen, all of them makes up this one. All of them can be found in this. So the resulting gas is here is going to be addition of all these things that we have here. Here we have our A plus, that we have a 0. This one will give us 5, 9, 10, 11 plus 1. We have a 5, 9, 11 plus 1 have 2. Then we have a 2, 2, Cl2 of what? The resulting gas. That means the resulting gas now. Resulting gases will be 2, 2, Cl2. That's our final answer. Thank you so much for watching. We hope that you come again and subscribe so that you'll be able to be getting our updates. Thank you so much.